Lesson 64 has two parts. The first part is on domain, and then we'll be also discussing the additive property of inequality. To understand what domain is, let's just go ahead and do a practice problem. In practice problem A, I want you to graph that inequality on a number line, x less than -3. And then you see to the right there, there's a description of a set. D equals integers. Well, that D stands for domain. And there's just a set of numbers that we can use for the domain of x, or for acceptable values to put in there for x. And we're defining here that we are just going to use the set of integers as our domain, or as our set of acceptable values to place in there for x. Before, when we've done these inequality problems, we did not define whether we were going to use real numbers, integers, whatever. We just assumed real numbers. So now we have to be more careful with our selection of acceptable values that we place in there for x. Let's just make a number line. And for this particular one, we're graphing x less than -3, and the domain is integers. Well, just think about this. If the domain is integers, if the acceptable values that we can use for x are integers, we cannot just start with a line and start shading in to the left. Less than -3, the first integer that would be less than -3, that would be a -4, because we're not including -3, right? So we put a dot at -4, then we can put a dot at -5 and at -6, and then we'll shade in the arrow to show that we are continuing on to the left. So that is the representation of x less than -3 when the domain is integers. So the domain, that's the set of acceptable values that we can place in there for x when we make our number line and graph our inequality. Before, when we've done these problems, we just assumed that the domain was real numbers. We didn't even say anything about it. Now we are defining our domain more carefully. So look at practice problem B. X is not less than -3. So that means it's going to be greater than or equal to -3. So let's just rewrite that. If it's not less than, it's greater than or equal to -3. The domain is the positive integers. We need to take that into account as well. So we have our inequality there, and our domain is positive integers. So that means starting with 1, that's where we would have to start, because we're going greater than or equal to -3. We can't start with -3 or -2 or -1 or 0. We have to start with a positive 1. And so we put a dot there, and then we can shade in the arrow. I'm just using that same number line for practice problem A. That would be the description of that inequality on a number line. Well, in part B, we'll also be talking about inequalities, and in particular the additive property of inequality. Basically, it's just like the additive property of equality. Look at practice problem C. X plus 5 is less than 7. Now, what you would want to do on a problem like that is first get the x by itself, because that's always how it is in an inequality, right? We don't have anything else that's with the inequality. So you just subtract both sides of the inequality by 5, just like you would if that was a equal sign instead of a less than sign. And so you end up with x less than 2. And so to graph this, we just make a number line. And on our number line, we first need to look at our domain. The domain for this particular inequality is the real numbers. So to graph that, we need to put an open circle at 2. And then we'll shade in to the left. We'll shade everything in because the domain is real numbers. We don't need to put dots or anything because it's not integers that we're talking about. we're talking about real numbers. So that's all the numbers on the number line. So that would be the expression of x less than 2 with a domain of real numbers on a graph or on a number line. Let's do one more. X minus 3 is greater than or equal to 7. And we have a domain or an acceptable set of x values to place into that inequality of integers. And so what we do is simplify that first by using our additive property of inequality. It's just like the additive property of equality. We'll add 3 to both sides of the inequality, just like if it was an equation. X is equal to, or x is greater than or equal to 10. So let's make a number line. You need to make sure you include some values on your number line that will be able to represent your inequality. X greater than or equal to 10. So that means we can start at 10 because we're saying greater than or equal to, and our domain is integers. We put a dot at 10, just kind of like a closed circle, another one at 11, 12, 13, and then we'll shade in the arrow to show that we are continuing on to the right. So that would be the graphical expression of x greater than or equal to 10. So the additive property of inequality is just like the additive property of equality. Okay, well that's all for lesson 64.